Okay, last time, I hope that everyone is here. I don't want to wait anymore because every time we have a class, we need to wait for others to join the class. So it's going to be took some time. Better for us just continue our class and might be they can also watch back the video recording. Okay, in terms of thread last time, we looked into two things on the overview and also multi-core programming. We did take a look into the components inside the thread. We have three components, which is program counter, set of register, and stack. And then we know if you are given with a single core compared to the multiple, you're going to have a single or one thread only in the system for the single. But if you are having a multiple core, multiple processor, you're going to have several threads inside, isn't it? But although you have many threads inside, maybe you can have 3, maybe you can have 4, there are still items that you're going to share together with all those threads. This one we already looked into in our previous class. And what is the item? The item is code section, data, and other operating system resources. So in terms of the view, this is the view in graphic, in diagram that you can relate from our first slide here. So we relate it here. When you are having a single or multi-threaded processes, here you have only single threaded. Going to have only one. This up here, if you compare to the multi-threaded process, you're going to have similar thing, which is related to these 3 points that you share with all the threaded. So if you have a single things, you're going to have this, which is similar, but you're going to have only one register and one stack for one thread. But when you have multiple threaded, you're going to have each threaded 1, thread 2, thread 3. These all thread, each of them are having their own register and stack. They have their own register and they have their own stack. They have their own register and stack. But they're going to share. That's why you didn't see any like divide table here. Instead, they're going to share all of these to all the thread. Thread 1, thread 2, thread 3. So that is the meaning by these sentences, okay? You're going to have the item that you're going to share together. And this is also how you're going to tackle your question, test 1. Test 1, I already submit the question, and others lecturer, Dr. Shahida also already finished the question. You need to know that all the question will be coming out from the slide. So it's quite hard for us sometimes to ask a question. So like this example of this slide, we can just like mention, okay, what is the item that not, might be it's not, okay, not share to others, or might be not share to others with or between threads. So we will give you A, B, C, and D is the one that is wrong. Or maybe we can just change the sentences. So it can be one of question. Maybe you see and you think that, okay, it's easier because it's coming up from the slide. Okay, might be the question will be like 20 to 30 question for multiple choice question. And when you are having module 1, module 2, and 3, because we have only 3 model to cover for your test 1, okay? Test 1 until module 3 only. And there is no lab question. So from your lab, you learn how to list LS. There is no question from lab. There is no information related to your lab 1. Okay. So it's totally from your module slide 1 until 3. And from here, might be you can see it is like 50 pages, 55. Might be this one is 40 or 30. So altogether, you're going to have like something like this or near to the 150 pages. So when you want to try to find the exact slide, so you're going to take several minutes. For each of the question, maximum you can occupy is about 2 minutes. If you apply 2 minutes, also sometimes you don't have time to finish all. So that's why please make sure don't like think that okay I can compare to the slide, although it is a closed book test, right? I don't know because it is all online, but this is what I want to remind you. Please don't think that okay I will remember that letter, so you didn't exactly memorize all the things. Okay, so that is on the basic informations about thread, your definitions, and several informations about thread. And you can see also last time we have taken a look into there is a 3 things under multiple action when you executing simultaneously your program and etc. So you have first heavy web process, and normally it is a old version traditional process. This heavy and lightweight having 2 different things, which is heavy is passive and lightweight is active elements. And in terms of heavyweight, it on the resources, while for lightweight, it use the CPU and schedule for execution. It's going to use the CPU. That's why it's not too heavy. It's not going to store in their own resources. This is our thread. But this one is like a single thread in one program and process. But when you are having, now we are having multi-threaded application program, and normally our machines, laptop, computer, and etc., most of that is using a multi-threaded process. It contains several threads which can run at one time. After this, you're going to see also that you can, okay, at this one, you can do your thread using a parallelism. You can have 2 threads in one time. Let's say over here it is 0.001 millisecond, similar to this, okay? At 0.001 millisecond, you have 2 threads that are running because you are having 2 core. You divide it into, but the thing is you run 2 threads. If you compare to the single core, you can run only 1 thread at one time. So this is what is mentioned here about our multi-thread applications. You can run a thread running at one time, several threads. And then, wait, yes? Coming in. I have class now. Can you wait for me a while? Maybe, did you bring any laptop to with study? Because I need to take the picture of the raspberry first. What? I think over there. Maybe you can check because the connection yesterday, they pull out the wire. One of the wires already pulled out. So we just put something there. You can check. Okay. Sorry. There is my student here. Okay. That is about our multi-threaded application. And last time in our previous class, we did take a look example of multi-threaded. And your friend also, I can't remember whether it is come from this section or different section, mentions about your web browser things, like your Google's, Firefox, isn't it? Is also example of multi-threaded application. Okay, here in your next slide, last time we take a look about thread versus process. And process you already been through in our module 3. And you need to know that items shared by all thread in process. So what is the item? An item private to each thread. For per process item, so there is a list of all the item. You need to look into one by one. And per thread item, example like program counter, register, stack, and stat. And last time also in our previous class, this is the flow that I relate with your computer system. When you are having the input and then processor and output. After that, you can see here when you are having you as a user and a client, of course, when you want to apply into the server. Let's see when you are trying to open www.google.com. So Google also having their own server similar to our UTM. Let's say UTM are handled, all the server are handled by KECIL, isn't it? Okay, so let's say we have here KECIL, which is handling the server. We are at, might be their school computing, school electrical, SKE, mechanical, your college, KTDI, KTDI, KTHO, and so on. So they're going to separate. Might be before that there is another server before your main server on the KECIL. And here might be here at N28E, and this is me. When I try to open my, try to connect to the UTM Wi-Fi, I need to request from my KECIL, my server, to give me a permission to use UTM Wi-Fi. And I provide with the information. When I try to request to using the UTM Wi-Fi before I can go to Google. Okay, Google after that another one more time. But now when I want to use UTM Wi-Fi, I send a request. I click first at the Wi-Fi. UTM Wi-Fi. And then the server CICT will notice I want to connect to UTM Wi-Fi. And they're not going to give me a permission directly. Instead, they're going to ask me to provide additional information, which is a username, password, isn't it? After that, I flow here and server will check my information. Okay, then if all correct, they're going to give me a permissions. That is what is happening here when you have a server. But when you want to try to go for a Google, similar also you as a client, you try to go to www.google and you send a request. That's why if you have quite low, I think nowadays you going to have very fast, just a blink of eye, you can open your Google. Last time we have like a maximum of our speed like megabytes per second. Now I think it's more than 2 gigabytes. Quite fast, isn't it? So when I try to request Google.com, I send a request to the server. So basically they're going to process, okay, is it okay or not for them to give a permission. So suddenly you can open. So that is what happened when you are dealing with a server. You send a request and the server will accept to create a new thread to service the request. So basically after this, okay, this is the process only on the thread to open your web browser to google.com. Sometimes there is also a private website. So you need to provide you with the additional information and etc. So that's why in terms of your computing also you need to have something in between if needed. Okay, if there is no any requirement for authentication, so it's normally it's directly. So this is a flow of multi-threaded server architecture. In your test one, I think in your part B, I also already forgot, there is a like might be, where is the picture that can give the example? Maybe I give the example of this lah. Okay. You can check because you have module 1 until module 3, right? So might be, I don't know whether the question will be removed or not, but you're going to give with the picture, exactly picture from your module. Might be for module 1 or might be for module 2 or might be module 3. So this one we will remove or might be here. So we put A, B, C, D. So you need, you were given with A, B, C, D. So you're going to fill in, or there is a drop down button for you to select which one is the correct. Of course, we're going to give, let's say there is 4 empty space for you to fill in. We're going to give you like 6 or 7 option. So you're going to be like confused which one is the correct one. Not if 4 box, you were given with 4 answer only, no. Because it can be easier for you to pick, isn't it? So that is some of a question that can be asked in your test 1. I've been through several, but we still not yet read. Might be the question will be stay in your test 1 or might be it can be removed. Okay, we also look into example last time in our previous class. I think we need to finish our module 4 last time, right? But we did some recap so that you can get more understanding in the thread module 4. in terms of the application, you're going to have the several example. I give you example. First, like my word processor. You have a lot of application that use word processor, Microsoft Word, Notes, I can't remember, like PDF. So all of this is word processor. Will be used a word processor. And what are thread versions or item that can be available for word processor? It is a displaying graphic. So it's going to display a graphic. What is the graphic that will be displayed? Of course, your Microsoft Word things like files. This is all graphic. If you still remember about the GUI, things that you can see in terms of like more on the picture things. And what else you can have? You can have also reading keystroke. So you're going to see might be word count. So you can count using a keystroke. Maybe you can also check the error and also correlation between each other in terms of grammar. So this is on word processor, but sometimes your word processor also require you, because this one is just example, and there is also can be added into the thread, what is threaded that can be putting into your word processor. What happened?
This need to even cut and I don't have the soldering machine. I borrow it from my friend.
It's okay. I think no need for you to make it to be exactly. I think you can just connect it, because we don't want to put the exact camera in there. It's just a dummy one.
So you don't want this to move around in water?
I just want it to move around. Just now it still can move. Or you take off.
No. The thing is that this wire isn't connected. This wire, this black wire. So how it can move?
Let me check after this. Okay, you can see here, although you are using Microsoft processor, I don't know your Microsoft Word, but mine, sometimes I need to connect to the server. Okay, sometimes I need to connect to the server whenever I open my word processor, which is I need to have another thread that retrieve data from a network. So it can be that I have another thread depending on the process that needed for my program, for my application. For web browser, of course, normally you're going to need a thread that retrieve data from a network, because you are dealing with the network, with the internet, isn't it? And another trick that can be available in the web browser in terms of graphic, also displaying your image and text. So it's more on graphic. While for the web server, as we are a normal user, normally we rarely to deal with server, because server is handling by like a server engineer, technicians that are dealing with server. So we rarely find out server things. But I think like data communication subject, there is a lot of other subject that are dealing with server. You're going to use like Apache, packet tracer software, all those things you can see on the server, which is you're going to see a thread that are having a request to the server, and thread that can create the service from the request. So that is an example of application, because you have a lot of other example, uh, a lot of other example that you can basically having a thread. And why you need the thread? What is the benefit or advantages of the thread? So here in our module 4, we are displaying 4 things. We are sharing 4 benefits on threads. First is on the responsiveness. Second is resource sharing, because you know that the thread going to share resources on the process. Economy, all this, I think, I don't know about the economy, but it's mentioned that it's cheaper than process creation when you are dealing with the thread switching, lower overhead than context switching. And lastly, scalability, which is a process can take advantage of multiprocessor architecture. So this is all the advantages that you need to remember. And normally might be we can give in terms of sentences on the advantage. So you need to pick out whether it is advantage of the thread or we just make up the sentences for you. So next we look into multi-core programming. In terms of multi-core programming, we have 3 things that important here in the slide. We have multi-CPU system, multi-core system, and another one in the multi-threaded itself for the programming. Okay, let's take a look one by one. Okay, in multi-CPU system, multi-CPU are placed in the program to provide more computing performance. So this is information about multi-CPU system. If you were given with this without knowing what is multi-CPU system, maybe you can think that you are having one display. You're having the one display here, and might be you have CPU, and then you connect both CPU to one system, might be because it is, can be to be a multi CPU. You have to CPU multi, right? And you place in a computer to provide more computing system. Might be in one application you can run there. Might be another you can run in using the another CPU. But of course, multi CPU, you just see it one CPU, but inside here we are having a multiple CPU inside. Okay. Mushroom, Caesar, you want to go back to do the things? No.
Because this phone needs soldering output cannot do because motor does have only one connection. It needs two connection. One connection only.
Okay.
I
Next we have multi-core system. On the multi-core system, it have multiple computing core. This one is our normal computer. In our CPU, we have several multi-core, which is we also already learned on the COA subject, which is a place in a single processing chip where each of the core appear as a separate CPU to the operating system. On the multi-threaded programming, it's going to provide a mechanism for more efficient use, especially for multiple computer core, and improve the concurrency. This is the first term of currency that you meet. Later on after this, you're going to meet a lot of concurrency things. So on the concurrent Last time we already looked into until here. This slide, I still remember. It is about a type of parallelism. Last time, yeah, we're not going to go deeper on currency anymore, right? So here on the concurrency, after this, we will go deeper. Okay. So before that, you need to know about multi-core programming, which is you need to consider an application with 4 threads first. So this is example. If you are having an example of having 4 threads on a system with a single computer core. This is all version of computer. Concurrency means that executions of the threads will be interleaved over time. So might be you cannot understand in terms of sentences, but we're going to have the example later on here in a diagram. I will explain it, okay? And another one more things, if you are having the 4 thread example, okay, you need to consider application having a 4 thread on a system with a multi-core. However, concurrency means some threads can run parallel because system can assign separate thread to each core. Okay, so let's take a look into the example first before you forgot. We look into first statement about concurrency. You are having only a single core. The statement are saying about a single computing core, single core only. That's why you can have only one parallel things here happen here. One core and concurrent execution on single core system. Let's say you want to try to open Excel, and it's already mentions that it is 4 threads. So you need to have T1, T2, T3, and T4. Okay, so you have 4 threads all together just to open your Excel. So might be for this thread is going to like try to look into your graphic. Might be this thread are trying to see in terms of your network. Okay, example here. Might be Excel. Another one is looking into what thread to have words counting might be. So you have several other thread. Okay, we have 4 here, and it cannot directly do it all together. That's why it's slow. Because after you finish like 4 thread, and you can open your Excel. This is the process. So it's going to do first. Okay, let's say for thread 1 is going to do first. After finish, then it's going to do another thread. After finish thread 3, 2 go for thread 4, and lastly for thread 4. Might be after here you already successful execute your Excel. It's depend, but you can see on time it's going to be only one thread at one time. Might be we can see it in terms of, okay, assume it's to be millisecond, okay? 1 millisecond, 2 millisecond, 3, 4, 5. Let's say until here. We assume until 4 millisecond. And we assume it's to be execute at this time. So you need 4 millisecond just to execute your Excel. If you compare to the parallelism on a multi-core system, example in your machines, you are having 2 core, core 1 and core 2. So the statement mentioned here, assign separate thread at each core. Okay, so you're going to assign, let's say at core 1 at 1 millisecond, you're going to have thread 1. And at this 1 millisecond also, you're going to assign your thread 2 to the core 2. So this one is core 2. And then after that, at 2 millisecond, you're going to have thread 3 and thread 4. Can see after your thread 4, normally we assume just now after thread 4 is going to execute our Excel, let's say, right? So how fast it is compared to the single core, you need 4 milliseconds to open one application. But in a multi-core, you can open 2 milliseconds because you divided all the thread to the cores. Okay, so that is the example between your concurrence and also parallelism. So back to here. So that is a statement, and just now is explanations in terms of a graphic and diagram. There is a fine but clear distinctions between concurrency and parallelism. It mentions that they are having a very clear differentiation just now about your concurrency and also parallelism. A concurrency system support more than one task. You can have more than one task. You can have even 4 tasks. But you're going to allow all the tasks to make a process, of course. But of course, you need to do it one by one, right? In contrast, a system is parallel if you can perform its one task simultaneously. So that's why it is also possible to have concurrency without parallelism, because this one you can have all the tasks just using a concurrency, which is one single core. You can have all the threads, but of course you're going to do it one by one, okay? Without having the parallelism, which is you're going to divide it, you can also finish it using a concurrency for all the tasks. There are several types of parallelism. Okay, in our OS subject, we just look into two things on data parallelism and task parallelism. But later on, if you take a HPC subject, you're going to go, there is several other parallelism type. Okay, let's take a look into what is data parallelism. So data parallelism is going to distribute subset of the same data across multiple core. So you're going to distribute on the data. So you're going to distribute to all multiple core, same operations on each. While for the task parallelism, you're going to distribute threads across core. Each thread perform unique operation. So just now you can see, let's say, we look into task parallelism. We have, let's say, 4 threads. We have 4, and we're going to have 3 core, let's say. So we're going to distribute all the threads using task parallelism. Maybe there is another one, going to wait for another T1 to finish, and T4 will be here. But you're going to separate it. You can see we're going to distribute. Thread 1, as mentioned, is thread 1 normally is going to deal with like maybe network. This one going to deal with graphic. Another one will deal with your words or sentences. So they are having their own unique operation. They have their own operation. Okay, so that is the information about task parallelism. While for data parallelism, let's say you are having a 3 core as a similar example here. You're going to have a multiple core, which is 3 core, core 1, core 2, core 3. You're going to do a SAM operations, means SAM thread. Thread 1, thread 1, thread 1. So you are doing similar operation, but you're going to distribute the data to all the core. Similar also as what we are dealing with these sentences, like a data section of a code or section. This is all about data that we are sharing it all with all our cores. So that is the differentiation between data parallelism and task parallelism. Only two parallelism types that you need to understand. Next is, as a number of threads grows, so does architectural support the threading, which is CPU have core as well as hardware threads. Consider what is this, which is you try to Google to look into what is exactly Oracle Spark T4. It's going to have 8 cores at hardware thread per core. So this is the example of the architecture. In terms of multi-core and multi-processor system, they are placing pressure on programmers because there are a lot of challenges. So what is challenges when you are trying to dealing with multi-core and multi-processor? The challenges are like having to divide the activities, on the balancing, data splitting between each other, data dependency, and lastly, when you are trying to testing and debugging. So this is challenges by a programmer when trying to dealing with a multi-core and multi-processor. Although you are currently using the multi-core, you are thinking that, oh, it's very easy just for you to like open, press the power on your computer, on your laptop, it's already pop up. But actually there is a lot of headache from the programmer before this. Try to make sure that all the multi-core system are incorrect. Especially this is the major problem that they are facing. And in terms of parallelism, implied to the system can perform more than one task simultaneously. This is repetition. You already know that if you are having the parallelism, you can have all the tasks distribute to all the cores that you are having. If you are having 3 cores, you can separate all the tasks to all the cores. So of course you're going to have more powerful, more fast and robust in terms of your machines. While concurrency support more than one task making process. Example of the concurrency is a single processor or core, which is when you are trying to provide scheduler providing the concurrency. So this is the example just now we already looked into. And Before we proceed with concurrency, maybe we can have a Q&A. Is there any question? If there is no question, can we have a break 5 minutes? Then we continue back. After we continue, please make sure all of you enable your webcam, okay?
Okay, Doctor.
Yes, doctor.
Thank you. Okay, class, we continue with our module. Please enable your webcam, and we're going to continue with our concurrency. Where is my what? Webex. Okay, we continue with our concurrency. So concurrency normally it is in a uniprocessor multi-programming system. So uniprocessor, you already know that you are having only one processor, and we apply it for a concurrency. And concurrency will execute of a processes. Your process might be you are trying to open your application, so we call as a process, isn't it? We learn it in our module 3. And our threads are interleaved in time to yield the appearance of simultaneous execution. This one you already also looked into your previous mention here. Where is it? This statement is just a recap. Similar also in this picture. It mentions about the concurrency. Jauh okay. Concurrencies that is going to execute. Ya Allah, Akbar time ni lah. Wait lah, I get call from industrial. Wait for a while. Sorry class, because make you waiting. This is a call from industrial. We have a collaboration with industrial about blockchain. Normally, if you can see that, although we are a top university in Malaysia, but if you are looking for lecturer or might be in term of technology of blockchain in UTM, you you're really hard to find with. So that's why currently I was like try to approach, even though our school, they are really hard for us to go for blockchain. So I try to push it because you can see MSU, MSU, UMP. Ya Allah. Also already have a diploma in blockchain. UMP are trying to apply now. And then in terms of certification, UTEM, UPM, I guess so. They already have their own certification using blockchain. If you graduate next time, if you graduate, you will be given with the certification, right? It is hard copy, isn't it? UTM will be give you hard copy. So in time, this hard copy might be lost, might be there is like faded, and in time it's easy for you to get lost. And sometimes it can be also a fake certification. If you lost it, someone will change the name for the certification. So that is why currently we need to move to blockchain. So you will only be given with the digital. So it will be approved. I think you know already about some sort of blockchain. So that's why I hope that UTM will move later on. So that's why this company approached us to provide with the private blockchain training and etc. And upcoming, I'm going to get PhD student for blockchain also. So we're going to explore in blockchain later on. I hope when you are graduate, you will get a certification on blockchain, not just a hard copy, which is with all versions of certification. Okay, let's move to our module on concurrency. Just now we look into this point number 1. So next we have it is also known as concurrent process, or might be your thread execution. Note that actual parallel processing does not occur in your concurrency. You're not going to have a parallel things together. As 1 millisecond. So you cannot have a parallel processing on your concurrency. This is the informations on concurrency. Example in the uni process. Let's say you have P1, process 1. So you going to have, let's say example here, thread 1. So if your thread 1 run, you can see there is no process 2 attacking. There is no process 3 attacking also. After you have done with your thread 1 in your process 1 or process 1, you can see it's going to be tagged and will be replaced with your process 2 here. And similar also, process 1 and process 3 will not going to happen because also this is uniprocessor. And you cannot have a parallel process in one time. Similar also here, here, and here, and so on. Only one process in one time. But you can see here in terms of comparison when you are having a multiprocessor. actually is quite similar also on this diagram when you are trying to compare with each other. But in terms of this view, you can see, let's say you are having 3 process. In multiprocessor, what can happen is sometimes you can have a parallel processing. Okay, sometimes you can have, but sometimes you can also have like exactly they are doing it together, similar to this example. At 1 millisecond, they are doing a thread 1 and thread 2. But here, you can see might be in the beginning of like 1 millisecond to 3 millisecond, you just run process 1, and then at 3 millisecond to 4 millisecond, you going to have parallel processing, which is at this part you run process 1 and process 2 parallelly together. So that's why it's mentioned sometime occur. Okay, you can see also here at this section you have a parallel processing, but in the between sometime we cannot have. So overlapping and interleaving process execution is happen. Alhamdulillah. Example here, this one is also having a parallel processing. Okay, concurrency arise and occur in 3 different contexts. So what is the context or like trigger to make the concurrency to happen? First, please remember in your mind when you are trying to deal with concurrency, it is normally in a single core. So it's going to trigger when you are doing a multiple application. You try to open Excel, you try to open Words, you try to open your PDF. It's a multiple application. What is happen when you are trying to you are opening multiple application? Multi-programming was invented to allow processing time to be dynamically shared among several active applications. So you're going to dynamically share among your active. This is all your active application, and you're going to allow it to process. So that will be a multi-application which going to trigger your concurrency. So you still need to remember and see how the concurrency will be happen, okay? Next is when you are having a structures application. So in terms of a structure application, application can be set of concurrent processes. And another one is operating system structure. When you are having a operating system is set of process or a thread. So this is an example that when you are having a operation system structure. And in terms of this segment, interleaving and overlapping executions of a processes can be viewed as example of concurrent process. It is just another similar statement like previously, and we're going to go deeper in the control synchronization and also your data access synchronization in your chapter 6 later on. After you are dealing with the calculation and so on, we're going to look into the synchronization. So both of it present as a same problem when you are trying to having a sharing global resources. So what is the example problem when you try to do it, which is a global variable when you try to share file or database, managing the allocation resources optimal, such as this request use of the particle input output device, which going to lead to your deadlock. So last time I think your friend asked me about the deadlock and we already tried to look into it. And in terms of concurrent programming, concurrent processing system, one job use several processor, which is a multi-processor. Execute set of instruction in parallel. You're going to execute it when you are having a multiprocessor. You can execute it parallelly. And you're going to require a programming language and your computer system support to have the concurrent programming. Okay, here is example. Although, okay, you're going to give with your equation like this. It is a mathematical equation. Application of concurrent programming. When you want to deal with your programming, what happened last time in your COA subject? You need to do what? You need to do one by one, step by step, in terms of command programming. Let's say you're going to execute the line of, first of all, you need to store, right? Store D plus E. Maybe you need to add first. Add D into your EAX D. So the value of D, you're going to store here first. And then move. Might be you declare first also can. You just directly add them together. Add. You already store, assume that you already store EAX, EBX. Add the EAX with your EBX. So when you add, and then you're going to move it, you're going to store it back to the EAX. So one by one, you can see this step, you're going to do it first. After that, you're going to go to the next. After that, you need to go to the next, which is concurrency programming. You cannot directly write all in one single line and execute and get the answer. So how actually will be happen when you are doing uni processing, which is one core only. So you're going to do a sequential computation. First, what will happen in terms of mathematical might be you can consider this and this first because of the factorial, isn't it? So you're going to store the value after you subtract f minus g. Might be you store in your thread 1. And then after that, you have the value of this. You store in the thread 2. And after that, you're going to do the power. And then you're going to store it into your thread 1 back. Because you can replace after you get the value, isn't it? After that, might be after you finish this side, this will be your T1. Now, you're going to have all this value going to divide with your T1 later on. So what happened? Oh, it's directly do first this 4 divide with T1. After that, you multiply this value. 3 multiply with B. You can see it's not directly. You do it one by one. You cannot do it all together directly. After that, you go one by one. It is called as a uniprocessor. Okay. The sequential computing of the operation requires several steps. So you have altogether 7 steps to just fulfill one equation here. Next we have here, okay, this one is similar. Step by step what is happening.
Doctor,
Yes.
are these normal, I don't know, mathematical operations? Because I see double asterisks. This is multiplication.
Again.
You see in the first equation, the one
First
in the
equation.
beginning. Yes. Are these normal operations, normal mathematical expressions? I see a double asterisks.
This is a normal mathematical.
Yes.
Yes.
I see double asterisks. What is this? Two
Use
asterisks.
this one.
Yes.
This is power of. Like 10 the power
So,
of something.
so it's d plus e power of f minus g.
Okay, yes.
Oh, okay.
This
Okay.
one is power of. Okay. So this is a equation for you to make it as a power of. I think this one, I don't know whether you can use the symbol or not. But this one is mentioned here. It is a power for the T1. Okay.
Thank you.
And then maybe you can also double check if I wrong about the power of. You can check what is the double star here. Okay. Just this one is show basically when you are having the equation like this, you cannot directly jump to the actions of result. You need to do a concurrent programming, which is doing a step by step, which is sequential computation. Okay, next, this one is similar. You are given with the similar equation here, but this one is using a multiprocessor. Just now is uni, okay? Just now is uni. Now you are having a multiprocessor. How you can reduce the step? Okay, now we are having, last time we are having altogether 7 steps. Okay, altogether 7 steps. If we are using uniprocessor, one single core processor only. When we are having a multiprocessor, we will reduce the step. First might be you can see, or it's directly do this first. You can see 3 multiply with b, and then after that what will happen? It's directly go to here. I think it's going to solve it one by one first. This and this. But you can see they are separating it using a processor. That's why you can see, oh, sometimes jump here, jump there. But you can pick this and put on your processor 1. Pick this, you put in processor 2. Pick this, you put to the processor 3. You simultaneously do it in one time, but you separate 2, 3 processor because you are having a multiprocessor. And of course, you already like having 3 things here and do it in one time. And then after that, you continue. Maybe after you get the result here, T1 like this, you put and multiply with C. And then T2 here. This answer, you're going to multiply with power in, you're going to put in the result T5 later on with this. So you can see another 2, you separate to 2 processor. This is step number 2. Might be also you can add another processor, which is the maximum. Let's say example here you have 3 processor, but you need to also check if you cannot do it another one, you need to wait another step, isn't it? But in conclusion, with this similar equation, by using you need 7 steps. But when you are having a multi-processor, you can reduce it to have only 4 steps if compared to the 7 steps just now. So you already reduce your time. So this one is example. So you can see only 4 steps that you can finish to get the answer. Okay, you can try to compare the step by step. Okay, now we nearly to finish our module 4. This is an example on how many threads that you have might be. How many process that you are doing currently. This is example of Microsoft OS. How that looks. I think last time in the beginning of our class also we already look into our task manager. So let's take a look on mine. Okay, this is my task manager. If you look into the example here, it is iOS. So iOS quite similar also. You have CPU, you have a system memory, and this is also mine. Okay. Okay, I have here. So I have a processor, I have a performance. So in my processor, you can see, oh, I'm having my 3 applications or program that I run now. And inside here, you can see still there is a lot of threads that are require me to use my memory, to use my disk. Of course, currently it is inactive because I just open it, but it is a passive there. My Microsoft Word, so you can see, although I have one application, but I can have several thread, which is I open module 4, I open module 5, it is another activities here. On the task manager itself, so you can see a lot of applications and thread that can be happen now. You can check in terms of percentage also, but I did realize that there is a lot of background processor. You can see here, a lot of background processor. You can check yours also. And this is all the thread that can happen to our computer. Although we realize it, although we are open actively, or maybe it's just a passive at the background. And this is also example. You can have the process time, the process name here. Processor similar also this. Processor like login window, menu tab, system events. That is what actually need to be done in your thread on the overview. So this is all overview and informations that you need to know about a thread. Normally the big things that you need to memorize or understand is differentiation between a single processor, a multi-processor, and how the thread can be happen compared to the concurrency. Because if you look into all the information repeating several times, just to make sure that you're going to understand it clearly, and example also been given quite similar. Okay, any question related to this thread? So after this, I hope that you can have a clue how you can also try to tackle a test 1 question, because just now I also give you hint how the question can be asked in your test 1, in terms of the diagram, in terms of might be you're given with like this information in one single slide, where actually the question can be asked from. Because I do believe this OS subject is not too many as in slides. So only few. If compared to the COA, you have a lot of slides, a lot of theory. Plus with also your knowledge on assembly language. You still need to look into your lab, isn't it? But OS, there is no related to the lab. Next might be we can just having a go through on the module 5. So I already uploaded the module 5 in your e-learning. But we're not going to touch module 5 today. Alhamdulillah. Okay, in module 5, we're going to play around with process scheduling. Just now in the beginning of class also, I already showed you, especially in equations. So I was like quite happy for this module, because lastly, I can play with numbers. But although it is a numbers, and also it's quite easy for me to ask you a question, especially when I just need to change the value. You need to remember how to solve the example given in your module. Just play around with the numbers here. I change the value. It is referring to one question already. Okay, so what else important? I think you just need to apply in the equation. The rest, still there is needed for you to touch a theory, especially in the scheduling, because scheduling is still new for you in terms of scheduling characteristic, or the algorithm of the scheduling. There will be several things like new also, like a burst CPU, what is the burst cycle, and might be also we can try the code here to make it pop up in your Linux, which is Fedora, right? There is also a state by state. This is like theory also. In terms of scheduling, as I mentioned, there is a new things for you. How you going to play around with scheduling? How the flow? What is the rules, especially for the algorithm? It is quite hard for you to remember all together, especially all the wording here. There are too many, right? So I think might be we can spot a keyword on all the scheduling things. Okay, any question? So before class on next Wednesday, please download the module 5. Might be in the equation, we can do it together. And might be we're going to look also how the lab 2 will be given later on. I need to ask our coordinator whether the lab 2 is ready or not. Any question?
No.
Okay, I hope that you can have like 15 more minutes to try to do test 1. I will give you currently direct I will give you past year. Wait, where is it? Okay, here. I will give you the past year for test 1. You can try to do it because there is a lot of question been given in this past year. Course assessment, test 1. This one were given with the answer. Should I give it or not? There's one with no answer. Where is it? Let me. This one is PDF. Maybe I need to ask. I need to ask the coordinator whether I can share or not the question for you. Okay? Because last time I thought it is a question, not with the answer. Normally, if with answer, we cannot give to the student. Okay, I asked permission from coordinator first. When she said it's okay, then I will directly upload to the e-learning. Okay, I will inform in the WhatsApp group. Okay, thank you all. Meet you again next Wednesday. Okay, bye bye.